connect the main power supply to the input of the digital voltmeter and analog input 5 volt. From here the main power supply goes to the circuit. Now switch on the circuit. Make sure your DC supply is in the fully anti-clock position, that is, here it should show 0 on the digital voltmeter. Now increase. Before starting with this DC supply, make sure you press the start button twice to make sure all your LEDs should be off. Again, if not, then just switch off the supply and switch it on again. This might be counted in the error, so there will be some error, but other LEDs are not glowing, only this LED is glowing, so it will not affect your result as much, only be counted in the error. Now increase the DC power supply with a gap of 1 or 0.5. It can be seen on the voltmeter. Suppose if we increase it by 0.5. Now increasing it by 0.5, press the start button twice and see the LEDs that are blinking in the to the corresponding D4, D3 and not the readings. Where the LEDs are blinking, you must write 1 at that D, and if LED is not glowing, you must write 0. For example, if here D5 is not glowing, then we will write 0, and D4 is glowing, so we will write 1 for D4. Now again increasing it to 1. It is approximately 1. After increasing it to 1, we need to again press start button twice, and now see the glowing LEDs. Make sure the LEDs which are glowing, you must write 1 at that place, and LEDs which are not glowing, you must write 0 at that place. The order in the tabular form must be written in the same way as given on the apparatus, that is, you must start from D0 to D7. After that, you need to do the calculations. The calculative part include first the calculation of the resolution, that is, each step contains the volt, that कि हर एक स्टेप में हमारे पास कितना वोल्टेज है. For that we will have 5 volts that we have supplied to it, and 255 are the total number of bits that we are having. Since we are having 8 Ds, so we will have 255 bits. The calculations are like, since we are noting here 0 for the LEDs which are not glowing and 1 for the LEDs which were glowing, so count number of ones, and count number of bits as you do. Suppose if you have D0 means 2 raised to power 0, it's 1. 2 raised to power 1, it's 2. 2 raised to power 4, 2 raised to power 2, it's D2, so it means 4. 2 raised to power 3, since D3 is there, so 8. This will give the number of bits contained in each D. So corresponding to that, we will calculate the total number of bits. For example, here if we take here, we have 7. 2 from here, we have 2. From here we have 4, so 2 plus 4 6. 2 plus 4 6, 6 plus 8 is 14. 14 plus 2 raised to power 6, that is 36, 32 into 264. 64 plus 14 gives you 78. So here we have the total number of bits. We have to calculate the output corresponding to this bit. It will be number of bits multiplied to the factor 0.0196 volt, because this is the factor that is contained in each bit, that is the voltage contained in each bit is given by this. So after multiplying it we get 1.53. We will calculate the percentage error by comparing it from the actual voltage that we have seen in the voltmeter, that is digital voltmeter.